Well, g'day, Max here again. Welcome back to the shop. So this is part 2 in our two-part series of our recuperator duplication. So if you missed part 1, we'll take a quick look at the part that we are duplicating. So this part here is an old recuperator shaft. This is the threaded section we repaired a couple of videos back. So what we are actually doing is reproducing 10 inches of this part of the shaft. This will get modified and done in a separate way for when the thing gets assembled. So in the last video we drilled and bored, and we have to screw cut an M24 thread in the end, and now we just have to duplicate the rest here. So we've got this thread on the end here to do. That is actually a 10 TPI 2¼ inch British Standard Whitworth profile thread. British Standard Whitworth, British Standard Fine, same profile, so either or. And then, yeah, we've got a couple of holes and flats to mill on the end. So at the end of part 1, we bored this to size, ready to thread. So we just have to cut a thread relief further inside, as we want at least 40 millimeters of thread. So we'll get a tool set up, chop that relief in, then we'll cut our thread as I explained in the other video. So we're going to screw cut it as deep as we can, and then just do a clean up with a tap, as the boring bar that I have is going to struggle to cut to full depth and not run out of clearance. So this height gauge I keep on center height for this machine. So I'm just going to bring the tool up till I just feel it touching, and then come up just a bit above center. It's not much, it's probably only 8 to 10 thou, you know, 0.2, 0.25 maximum. And that will allow for any flex. As soon as that threading tool, an ID threading tool, flexes, you're going to lose your clearance and your tool will start rubbing instead of cutting. And you'll end up with an excessively bell-mouthed thread at the start of your thread. Something like that feels good. I never actually measure the exact distance that I do go. I just go by feel. But it's in the range of, you know, 8-10 thou, like I say, 0.2, 0.5, sorry, 0.2 to 0.25 millimeters, depending, and that will vary depending on the length of overhang the bar has, you know, and the stoutness of the bar. But I never ever set them right on center. Right. So I'll just square the tool up to the lathe axis of center, which would be approximately there. So we'll bring the tool up. We'll just do a visual eyeball. So I'm just looking at the daylight. The other thing you have to be aware of too is when you use this style of insert with a semi-formed threading insert. So this part here will interfere with the pitch that we're cutting. So I've ground this away. So this part of the insert here and here used to be here. Now I've removed it so we can cut to full depth, well, pretty well to full depth. Otherwise, depending on what pitch you're cutting, this area here will knock the top off the rear of your thread. You'll get an ugly line down it and scrap your part. I'll show you briefly here what happens. So if you look at this partial profile part of the insert, So when we plunge in to cut our thread and we're at full depth, because this insert, this is on a 2.5mm pitch, we're cutting 3, but you'll see the second thread back how we're getting interference, and it will cut the top off the thread, off this thread here. So we're cutting 3mm in this case. So you can see there we have, it would have been okay, but that's the insert that I've got in that bar. It's already ground back, so I'm not going to rotate the insert. So we'll just go with what we've got. But yeah, with that 2.5mm pitch, you could see it was taking the edge off the thread here. And it was actually 2.5mm pitch a while back I was cutting, but luckily picked up on it before things got ugly, and was able to keep on, you know, with a slight adjustment, grinding the insert, and was able to carry on with no problem. Just something you've got to be aware of. So this lathe's been sitting idle for a few days, so I'll start it up in a low RPM, and I'll watch this sight glass for the oil pump to start pumping. And I'll let it run like that for a couple of minutes before we start putting it in the higher speeds. So there's a couple of things that I personally do when I do something like this. I've got a white marker, and I've marked the bar. That area there is going to be our thread relief. So if I turn to full depth from there, whoops, bloody camera, until our marker goes flush, that's a safe area then for when we're screw cutting to disengage the half nuts. And the other thing I'll do, so I don't, when I withdraw the thread, when I'm winding the bar back out of the cut, I'll just put the bar in slightly and I'll wind out till I just feel that bar touch the end of the work. Then I'll note the position of my hand wheel. So I can come back around. So when I'm cutting, when I withdraw, so we're taking the cut, I disengage, I quickly take the tool out of the cut. I can take this safely then straight to the 12 o'clock position, and know I've got from 12 o'clock to a little bit past leeway before I withdraw the bar, because if I don't, you run the risk of, if you don't withdraw it enough, you're going to plough into the thread you've just cut. If you withdraw it too far, you're going to be, the rear of the bar is going to be hitting on the thread that you've just cut, and it's going to munt it up slightly. So 12 o'clock is my withdrawal position. And that will make sure the tip of the tool is completely clear, and I still have clearance at the rear of the tool. So 3mm pitch right here. We've got 7, S1 will be our change gear locations. So we've got 1 and 2, so we've got to make sure we're in 1. We've got to switch from feeds to screw cutting. We'll just jog it a bit. So we're now in screw cutting. Our lead screw's turning, our feed shaft stops turning. To set our other gears, we release the lock. This comes around to S, and this comes around to 7, and re-engage. We're good to go. So our thread dial here, I always keep it disengaged when not in use, just to save any wear and tear on it. And just light, very light finger pressure, light nip's all it needs. So we're engaged. So I'll just run through, I think I explained it last time, this auxiliary mark that I have on my thread dial. So when our lead screw's rotating and the dial comes along, just say for example this letter F here, it comes up. when it gets to that mark, I put very light pressure on the half nut engagement lever, just very light. Now those half nuts are engaging on the crests of the thread of the lead screw like that. So as we continue on, I'll feel it drop off the crest and into full engagement. So we're just touching on the crest and we're still going along, and it drops into full engagement. And that's the way I prefer to do it, rather than just sort of snap them in. I like to just feel it in and just light pressure. What can actually happen sometimes if you just snap them in, and you can actually grab on the crest of the thread and it will start feeding, and then you'll have a mismatch between your tool. You're not going to pick the thread up in the correct position, but that can happen. So with this metric threading dial, we have to be a bit careful here. So we're cutting 3mm pitch thread, so we need to make sure we have the 15 tooth gear on underneath, and D, E, F are the only numbers we can engage on. So under here we have our 15 tooth gear. There's other optional gears. We've got 13, 14, 15 and 22. This one's a 22. So yeah, D, E, F are our engagement points. We'll just re-engage it. Now, because our lead screw is a 6mm pitch lead screw and we're cutting a 3mm pitch thread, 3 goes into 6 evenly, which makes our whole thread dial redundant. We don't actually need to use it. But I'll show you, if I wind along, I can drop in on any of these letters. The only place it can drop in is on a line. So we're on a F, O, F, F, E, every hole's a goal, so it doesn't really matter. This is redundant just because of our thread pitch divides evenly into the pitch of the lead screw. So our thread depth we've got to go in is approximately 1.624. We probably won't achieve that full depth, but that won't matter anyway. Our true ID would have been 20.752. and we've bought it to 21mm, so we have a bit of leeway in there in those regards, as we will be running a tap down this thing to finish it off. So yeah, 1.624 would be our calculated depth approximately, and I say approximately due to this varies because of your tool nose radius, and we're running a sharp tool, so it's a very sharp tool. It's quite easy to undercut. Well, you will undercut, so we're just going to go as deep as we can. Okay, we're going to go into our required depth and do our undercut. Okay, it should be enough. Blow all the crap out of it. Feels like a big fuzzball up in there. It's stuck in the relief. Big fur ball, here we are. I think that's got it. So if we look up into the hole, we can see the rear of the hole where we've drilled and bored, and then a little way back there's another shoulder. That's the rear of the thread relief. You can't see the start of it. So I drilled and bored a little bit deeper, and that's to allow for like the bird's nest of chips that can accumulate up in there. Just gives it a bit of clearance. Right, we'll just do a scratch pass and verify our thread pitch. We're running on 500 RPM, 3mm pitch thread. And as close as I can tell, we are cutting 3mm pitch. That's good. So let's carry on. Just going to cut a chamfer first, 30 degree. Okay, we'll give that a blowout. Yeah, there's a fur ball right at the back. Right, we'll try our threading tap. Perfect. We'll just screw in our plug tap, which is here, just to make sure that we have got full depth right at the very back there. That one was a taper tap, intermediate tap, sorry. So this is our plug tap, or bottoming tap. Feels like it, we're there. Okay, so our thread came out pretty good. You can see the relief, maybe not, yeah, right at the back there. Good result. So that was screw cutting on 500 RPM. 720 was just a little bit too quick for the half nuts. Right, so I'll get this one out and the next one in. And the sounds of it, here comes the rain again. Well, it is the tail end of winter, I guess. Spring will be soon, and as soon as that weather starts to warm up, the snakes will be coming out again, out of their hibernation. So hopefully they're all next door and not here at our place. Okay, that one just needs a little bit of deburring around the edge, and the second one, I'll get that one in and I'll screw cut that one off camera, as you've already just seen one. Right, that's both of our threads done. That's our first one, and that's the one that we've just completed. So the next operation will be to tackle this thread here, the 2 1/4 inch British Standard Whitworth thread. So looking at this, they've got a thread relief in here, so we'll just duplicate the same. So we'll put a popper groove in here and here. We'll reconfirm our OD of the thread, so we may have to turn a few thou back, and then we'll screw cut it, and we're off to Olga to establish these flats. We're ready to put in our thread relief here. So the depth that we have to go in is determined by this chart here, basic dimensions of the Whitworth thread. So we're looking at depth of thread, come down in this column to 10 TPI, threads per inch. Depth of thread, 64 thousandths of an inch. Or rounded off becomes 1.651, and we'll take it to 1.7. It's only clearance. Right, we'll just double check our dimension back, which is 33 millimetre. Touch the tool, zero out our cross slide, and come in our desired amount. Okay, that's the first one. I'll break the edges when we do the thread. Just double check our depth. It should be right as we're coming up against a hard shoulder there. Yeah, it's fine. Right, we'll get our threading tool in. So we'll just check our threading tool against our pitch gauge, just to check, make sure we're going to have enough room, and yeah, we'll just get that. All good. We'll be getting a larger threading tool soon. And we are 57.35. So put that in the... $57.35 less 57.12, 0.23, 0.11 end feed. Uh, 2.249, right on the knocker. You'd think I'd get used to these conversions by now. Been doing it long enough. Okay, so that's 7 on our dial. We'll go back to 7 on our dial. Take this one out and I'll put the other one in. We're there. Okay, now now I did it that way because it's quicker to swap apart just for a quick turn on the outside than swapping tools when you're in the middle of doing a thread. That's the way I prefer to do it, do all the ODs and then come back, swap the parts out and do all the threading bang bang straight after one another. So let's get our threading tool set up now. Okay, I'll do a couple of chamfers and then we'll establish a 0 position on our cross slide dial for the end of the tool. Right, we'll just establish the depth that we need to cut in. So with this thread we'll be taking a slight different approach than the other one, seeing as it's a metric, full metric lathe and we're cutting an imperial thread. So we'll be running on 350 RPM. We've got our feed box set for 10 TPI, I hope. And we have to keep the half nuts engaged. We can disengage at the end of the thread if we choose and then re-engage on the same number for the return. But because this lathe's got a foot brake, I'm going to take advantage of it. So we're going to stay engaged on the O position, and there's only one O position, so you can't get it mixed up if you do accidentally disengage. It's not a problem if you do. All you've got to do is re-engage on the same rotation that you disengaged in. So it's just a matter of slowly reversing the lathe till you pick up your same number on your threading dial. Now the only thing with this lathe, as opposed to every other lathe that I've ever used, the forward and reverse is an electric switch. It's not a clutch lathe, and it's opposite to a clutch lathe. Well, at least all the ones that I've ever used. What that means is you pull the lever up, it goes reverse. You push the lever down, it goes forwards. So that will be the only thing I think that may cock me up in this. So if you see me going backwards when I should be going forwards, or vice versa, that's why. Because this is the first imperial thread that I've ever cut in this lathe. Like last week was the first metric thread I'd ever cut on this lathe. So fingers crossed we don't make a pig's ass of our part, because that would mean we'd have to machine it all back, weld it all up, remachine it, and then have another crack, well, another bite at the cherry. I think we'll be all right. Hardly a drama. So the cutting oil that I'm using, I've got no idea what it is. It's very similar to Rockall. It's some shit in the bottle. Now the bottle was full, but I'm getting towards the tail end of it. Yeah, no idea what it is, but it works absolutely brilliant. It's very similar to Rockall. Rockall, you've got RTD, which is your common tapping cutting fluid. I use it a lot for tapping and threading. And Ultra Cut Rockall. It's whatever's in that bottle is close to Ultra Cut, but no idea. It could be mixed with could be blended with a couple of different oils, who knows. Anyway, it works great. So we'll do a scratch pass and verify our 10 TPI, hopefully. Ups, down, downs, up. And we're on 10 TPI. Beautiful. A bit of oil. We should be close. I've got this is a nut that I made for a gauge some time ago for these threads. Need to go a bit more. Actually, I've got it written down what my end feed was, the last one of these I actually cut. Let me go and have a look. No, what I had written down was for an ID thread. So this is where the your radius on the tool will make you undercut where you really should be. So we've got virtually hardly any radius, and this thread has a substantial radius. So we've come in shy if we measure by pitch diameter. So we're just going to come in a bit more. Chuck a bit of oil on it. Okay. Just going to do a spring cut. Not much spring in that. Now I'm just going to mark the dial so for this cut so I know where I am. We're miles away, so I don't know what's happened there. Something has moved. We are a mile away. I'm going to have to pick this thread up again, and we're right on the last cut. Let me just back out of it. We'll just have a test fit first. Yeah, we needed to take another couple of thou. Something's moved. Okay, so I'm just going to sneak up to it. I'm actually going to put the lathe in a slow speed once I get to it. And we've got to try and pick this thread up again, pick up our depth. Okay, so I'm going to put it in 25 RPM. L, B, 25, and I want to wind in. Okay, I'm going to mark the dial there on my crossfeed. And I'm going to repeat that cut. And come back up to our cutting speed again. HB. And I'll just back it off to 240. A little bit of oil. I'm just marking the dial again for each cut now. And test fit our nut. Yeah, I don't know what actually moved. Starting to screw on now, so we're getting very close. it did it again. So we are 0.3 millimeters of end feed shy of that last cut. You know, because I did a spring cut. I'm going to have to check. Okay, let me mark the dial. Something's moving. Okay, let's go back. The other back. It's really scary when that sort of stuff happens. I just need a bit more clearance. Especially when you're on the last bits of your thread. It's good to get it on camera though. So that fits like a glove. We're there. We'll go and get our nut. So this is a test gauge that I made, but our nuts will be a slacker fit on the shaft. I'll just go and get our nut. So these nuts that we made a while back. So they're good, nice. Our ring gauge has less clearance because it's made as a gauge. Okay, I'll just do a bit of deburring on this off camera, and then we'll put the other one in. I don't know what's moved, why my dial has moved, I've got no idea. I'll have a quick look and see if I can see anything. But yeah, that was an interesting one to get on camera. Alright. So I just want to take some of the sharpness off this last thread. So when you file a radius, you don't go like with it, you go opposite. Like that. That's the correct way to file a radius. None of this malarkey here like that. You've got to go like, well, you don't have to go like that, but that's the correct way to do it. And that was part of our training as apprentice machinists, apprentice fitter and turners. You learn a lot about files when you're an apprentice. I'll just do the one at the rear. I'm going to use the edge of the file. Beautiful, all the way to the shoulder. Okay, let's get this one out and we'll get our other one in. This one here, and see if we can't get to the bottom. I'll just run over everything with a spanner. I'm sure if anything was loose, we would have had a problem with the thread depitching. It's purely an infeed thing that's happening, so it's possible I've moved the dial when I've inadvertently, I'll show you. Because as I said, it's not depitching, it's purely infeed. So it's possible, I haven't got this dial clamped real tight. It's possible I've moved it when I'm going to withdraw, maybe. If I've gone like that, that'll move it. That'll be what it is. So no worries, we'll just reset to 0 when we put our other one in. I'll do the lock screw a bit tighter. So we got a nice clean thread out of it anyway. That's the main thing. As far as reverse threading, starting in here and working back, I get a lot of people ask me why I don't do it. The reason I don't do it, because my personal opinion is it's a totally ridiculous method to cut a screw thread. Now here's a classic example. Imperial thread on a metric lathe. You've got to then drop your tool into this little spot here, set your depth of cut, and then take your cut. And then what if the drawing doesn't specify a thread relief? Well, then you're screwed. You know, not all threads have a thread relief. So there's just 2 points there. I could list multiple points why it's not good practice to get used to cutting in this bloody reverse malarkey. I think you're better off investing your time learning the 3 other basic threading methods, and that's straight infeed on your cross slide. The other one, you can angle your cross slide and you come back on your cross slide dial back to 0 every time and take your cuts on your compound. Or straight infeed on your cross slide and slowly bump your compound in every cut, and that'll stagger your cut. Those 3 methods are more valuable to learn than this back to front threading malarkey. If you only ever cut imperial threads, and if you've got a thread relief for every single thread that you cut, it probably work for you, but bear that in mind. If you've got a lathe, like a cheap Asian lathe, that has a poor half nut feel, you're going to have no end of trouble with your half nuts not engaging in the correct spot. You'll have misengagements left, right and centre and scrap your part. Cutting the conventional way, if you have a misengagement, you've got time to pull out before the tool starts cutting, where you don't have that cutting and starting from in a groove. So just my 2 cents worth on a couple of different methods of cutting threads. So anyway, I'll get the next one set up, and I'll film that one. I won't talk through it, we'll just film it. Okay, let's go. Bit of oil, lube her up. Do the old, there we go. Okay, a bit of oil. Get rid of that. Someone asked me the other day, what sort of oils can I recommend that don't stink? Well, I only know of two, which would be Anchor Lube and one we get over here in Australia. They get it probably in UK as well. It's called Trefolex, and they don't stink. But beware though, Trefolex, don't breathe in any fumes on it, because when there's heat involved with it, it becomes carcinogenic, like everything else on the planet. Okay, we are not far off. We're on 1.5. Ow! That was bloody hot, but went down my neck. Okay, this should be pretty well our last cut. Bit of oil. We'll do a spring cut after this and then try our nut. Okay, spring cut. Ooh, a little bit tight. Yes, we lost all our settings, you know, otherwise I could have come down first go. Okay, well our nut goes on, but our gauge doesn't. This nut needs a little bit more clearance. So we'll just take another spring cut first before we advance our tool into a new cut. Okay, so here we go. Yeah, it needs a bit more than that, I think. Try that. Fraction more. The other reverse. Okay, a little bit of oil on for the last one. Should be there. Absolutely perfect. No play. Which is our gauge size. And our nut will have a slight play. Could go a bit more, but nah, that's good. All right, I'll get this one deburred, same as the other one. And then I think we're going to head over to Olga because we have to look at machining a pair of spanner flats on the end here. So slight change of plan. I was going to do these spanner flats in Olga because the indexing head and tailstock are already set up on that machine. But due to these holes here and the fact that these, I can only grip these shafts right on the very end in my indexing head, and we can't put a center in here because it's going to bugger us up for whatever goes on with this hole here. So a slight change of plan. I'm just going to grip them in the vise in the Bridgeport, and we'll do it that way. So all we'll do, grip them in the vise, we'll machine it, then we'll rotate it half a turn, register off the bottom with an adjustable parallel or something along those lines, not sure yet, and then that'll have to do it. So all we'll do is we'll measure our OD here, measure the distance across the flats, it's not that critical, subtract across flats from OD, divide it in half, touch off and go down that depth, and that'll get us within the range of where we need to be here. So that's the plan. You guys may not see this, but there's some little spindly spider webs here. That's the sign there's a big redback somewhere. Clear them out of the way. We come up here. Behind that brown thing is a big fat female redback. You get bitten by one of them over here, they'll sit you on your ass. There, big fat female ready to pop out a heap of miniature redbacks. There, that's their most dangerous time. So we'll just get our depth set in our Bridgeport and then we can rock and roll. So I had a couple of really nice gifts turn up in the mail for my Bridgeport here. So from Gary over in America, this crank handle. Absolutely brilliant for when you want to drop the table down, better than cranking, you know, the big standard Bridgeport handle. The Bridgeport handle's good for coming up, but going down, you got a lot of arm cranking. And this little thing he made up, or organised for me, absolutely perfect. Beautiful job of machining the back of it. And fits great. The other thing he got for me, which just turned up in the mail just today, he's made up these concertina way wipers. So we'll get these fitted up. So this one's really nice, the way this sits. I'll show you. So this one gets attached here, and then the concertina thing gets attached down the bottom here, and there's the other one goes here, the front. So we'll get them mounted up, and that'll go a long way into protecting my ways. As every time I move the table on these, I'm always make the effort to clean all of the crap off it and put a bit of oil on them. And of course, yeah, the other one goes on the front here. So yeah, cheers, Gazza. That'll be great. Thanks. I think we'll just go across just a fraction more. Something like that. Okay, I'll swap the shafts and put the other one in and get the other one to the same stage. Right, now we'll rotate them around and we'll get this flat face clocked up, referenced on the underside. And this will be the perfect job for our adjustable jacks. That's it right there. Tighten her up. Tap it down. And away we go. Well, that's as far as we can go on these for the time being until I know the details of the valves that go inside these holes and actually how far we have to go with them. I think we've got to make up a couple of dummy valves that look like the same as the originals. So the thread details will possibly be quite simplified to what what you see here. So I have to wait and see till the customer gets back to me on that detail. Okay, well, we'll have to bring this one to a close. It's getting rather long. Sorry about that, but some people enjoy the long ones. So yeah, as I said, that's as far as we can go with that job till we get the remaining details and instructions on how they want to progress. So all going well, unless they get back to me by tomorrow, which they probably won't, but you never know. Oh, excuse me. We are going to be back on our JFMT tool post, so we'll finish the remaining details on the tool post stud. We'll get our new tool post mounted up and we'll go through a few details on the chuck and see how, well, then we've got to start doing some alignment tests on the lathe and adjustments. So anyway, cheers, thanks for watching, and you'll probably see me in the next video. Catch ya.